Hello, welcome back to this random table where I fix stuff. Today we've got this mid to late 1940s Philco AM/FM radio. It's a kind of a nice cabinet. Usually at this time, Zenith had switched over to the Bakelite cabinet, so Philco is still using wood. Anyway, we're going to see if we can get this working today. I haven't tried it yet. See the plug. So the piece has broke off the side here. Luckily I happen to have a piece here, so I have to see if we can glue that back on at some point. But first, let's just plug this in and see what we get. Should just turn it off. Plug it in. And let's see what happens. I don't really see any dial lights, not sure if it has any. There's something there. Volume control doesn't have any effect. Let's try. I hear a click when I change the band. That's tone, that's why. That's tone control. This is the volume control. Try AM. Sounds like we get absolutely nothing. Try FM. Sounds like we also get absolutely nothing. Just a slight hum and some crackling. No indication that it wants to tune in any stations. Okay. So let's open this up and see what we got inside. Now, I'm taking all the screws out of the back except for this last one. That one was missing, but let's take this last one out. Take the back off. It's a nice thick panel actually. So I'll think that usually these are pretty flimsy. So, well, okay. So we have here. So we have this thing, which is not connected to anything, which what the idea is with this. This is supposed to be like your FM coupling antenna. See what actually it would plug in there, I guess. It fits in. I'm assuming that's what that is anyway. That's probably a lot of these early radios took used the line cord as an FM antenna, and then just had like a little capacitor, which basically was just like in the case of the Zenith, so they just took a piece of sheet metal and clipped it around the line cord, and then connected that to the FM antenna. So it just basically formed the capacitor between the line cord, the insulation, and the plate clamped around it, and capacitor decoupled the FM signal from the line cord into the radio. It looks like this is Philco's attempt at something similar, although it looks like they just use like a regular like stress relief thing with a metal ring around it, and then I'm assuming that's what this is anyway, and that would be your FM antenna input there, I'm guessing. So, interesting way of doing it. I see we have a control here or something. Actually, you can't adjust it because it's bolted in, so I'm not quite sure what that is unless it pulls out. I better not mess with it. I don't know what that's for. Anyway, this wire is not connected to anything, so that could be part of the problem. Not sure where it's supposed to connect. I'll have to figure that out. This yellow one here is going right up into the tuning capacitor in there. Like we've got a lamp shield here. Don't really see where the lamp is though. Oh, there it is. That's probably. That was unscrewed, so maybe that's why we didn't have any light. Put this back on later. That was unscrewed. So let's see, this tube is
Wow, this tube is really out. So that means we see all these tubes. And we'll keep this plugged in here. I'm going to force it, but it doesn't want to go in all the way. See if that makes any difference. I'm still not sure where this is going to go, but let me see. Looks like it was stripped, but I don't see any evidence of it being soldered or anything. It sounds like a radio at least now. This is the FM, so hooking this up probably helped. Well, it seems like it's picking up stations, but it seems heavily distorted and pretty noisy. So, could be, bad capacitors. Obviously, I can see a wax capacitor peeking through there, so it's definitely a candidate. I don't really hear much filter hum though, so I'm not too suspicious of the giant filter capacitors there. Could also be crappy connections on the controls too. So anyway, I think the next thing to do is to figure out where this is supposed to hook up to, so we can try AM then, and also take the chassis out and take a look at what kind of capacitors you've got under here. Maybe you can take a look at that, and also take a look at the resistors, because off value resistor could also be probably be creating this kind of noise, because it did tune in one station clearly. So it could also be that this capacitive antenna is not quite as good as Gene's solution either. But we did pick up one station and it seemed pretty clear. So let's take this out and take a look at what we've got underneath. Okay, so I cleaned out all the controls and hooked up the antenna properly. So it turns out that the antenna is supposed to be hooked up to the screw terminals on the back. So that wire that was up here was actually not connected to anything. It was just like laying there and got stuck on one of the contacts here. It actually wasn't actually connected there. So FM sounds pretty much the same as before I cleaned the controls. Like 1 or 2 stations come in, but the rest are pretty noisy. However, you go to AM.
From burning down a city.
Now see that AM is working pretty well.
Sure. Essentially, so he turns down the unit.
Sounds pretty clear too.
A priority for later in life, and actuarially.
Your piece with this new deal. Now here comes COVID-19 now.
So that's why.
Wow. What I want to know is how does he hit the high notes?
You're listening.
So even when I turn the volume on, you can still hear that we've got some kind of crackling in the audio. It must be after the volume control, so it could be bad paper caps in that circuit, something's breaking down, could be resistor breaking down. Let's see, which way do I turn this off? I did check underneath here, and there are quite a few paper caps and black beauties under there, so probably go through and replace those and see if that takes care of our crackling volume issue, because it should be replaced anyway. We do know that the radio is functional, it just has some minor issues. Don't really hear any filter hum, so I'm not too worried about the filter capacitors here. This radio is actually rather interesting. So, let me turn on my lights. So these two tubes here are both rectifier tubes. They're both 117Z3 tubes. And when I first pulled this out and saw that, I thought that was interesting. So I pulled the schematic for this, and actually this uses a voltage doubler, which is pretty uncommon for radios. Usually TVs use those because they need the higher voltage, but usually radios, if they don't have a power transformer, they just use one rectifier and run directly off the rectified AC. So kind of interesting. This one uses a voltage doubler. Don't usually see that in radios. Another interesting thing is that it uses a separate mixer oscillator tube for AM and FM. So this right here is a 14F8. That's a dual triode Lochtel tube, and that is used for the FM mixer. Mixer and oscillator in that tube. And then there's another separate tube. I think it's either one of these two or not. No, actually, remember, is used for the AM mixer oscillator. Could be this one, because I think this one's used for the FM RF amp. One of them's a 12AU8, one of them's a 12AU7. So probably 12AU8, whichever one that is, would be the AM mixer oscillator, and then the 12AU7 is probably the FM RF amp. But anyway, 2 IF stages, and you can see we've got separate IF transformers for the AM and FM. Another interesting thing, the FM IF frequency for this is 9.1 megahertz, which I don't think I've ever seen that before. The more common one for radios after like 1947, 1948 was 10.7 megahertz, and pretty much every radio used that. And before that, I think they were like 8.1 or something like that megahertz. The original IF for FM, but this one's 9.1. I don't think I've seen that before. So that's another interesting thing. That mystery control on the back is just a radio phono switch. I took off this plate, which was locking it. So that little cutout there was locking the control in place, and that plate actually covered up. Not sure if you can see it down there. That little connector there next to the control is actually the phono connector. So this chassis is actually used in 2 separate radios. This tabletop version, and then also a console version, and I'm assuming that phono control is only for the console version. But that plug and switch does look wired in, so this looks like a very early example of manufacturers just blocking off functionality that is functional and just blocking it out so people can't use it. But I guess if you have a screwdriver, you could enable the phono functionality on this radio. But anyway, the radio seems mostly functional. Just got that crackling to work through, and the weak FM, could be an issue with this antenna not being very good. This plug, I couldn't get this plug to go in any further, so not sure what the deal is with that. That plug, there's 4 pins on that, but only one of them is used on the connector, which is for the FM antenna. But according to the service information, they did make a dipole antenna that could plug in there that used more of the connections, because if you look underneath, there's actually stuff connected to, I think, all of the pins on that receptacle. So I can flip this up and show you the bottom. But before we do that, take a look at the tremors on the tuning capacitor here. Usually these are just like a stack of micro wafers with a screw down the middle, and you tighten the screw. Well, it's not just a stack of micro wafers, it's a stack of metal plates with micro wafers in between them. And then half the metal plates are connected to one side and half the plates are connected to the other side. So when you tighten down the screw, it squashes the plates closer together and increases the capacitance. Whereas if you loosen the screw, the plates spring apart and decreases the capacitance. However, these look like it's just an outer shell, and then you got a screw terminal here, which looks like when you turn this, it's going to push this post further into there. So I'm assuming that this side would be ground connected to this post, and then this side would be connected to the one side of the tuning capacitor. And as you turn this in, it's going to move this post through this further. And I'm assuming that that's all that would do, is just the more this post is pushed through these outer plates, the more capacitance there's going to be, because there's going to be more, more area of the post inside the outer shell here. And it looks like they've just got like a little ceramic dielectric separating them. So that's, I don't think I've ever seen that before, at least certainly not on a radio anyway. That's another interesting thing about this. So let's flip this up and take a look underneath. Alright, so as you can see, there's quite a number of wax paper capacitors under here. I'm not quite sure what I'm going to do about this one. It looks like they've got a coil wrapped around the capacitor, so that's going to be fun to try and replace. I could try sliding the capacitor out from the coil and sliding a new one in, but it's interesting. Have to figure that out. But anyway, actually quite a large number in here. Actually, if you saw before, on the back of the chassis it's stamped 49909. So the first digits are the model year, so 1949. But back then they released radios like they released cars. So model year 49 actually started in the middle of 1948. So this radio probably would have been produced either later half of 1948 or early 1949. It's actually interesting that they got so many of these wax capacitors in here, because around that time, I think Zenith had already transitioned to ceramic capacitors for most functions in their radios. If you work on something, late 40s from Zenith, this is stuff that I've worked on is mostly ceramic disc capacitors, and then they'll have like a couple paper capacitors. But this seems to be all paper capacitors and no ceramic. So probably get started on changing all of these out and see if that makes any performance difference. And if it doesn't, then we can investigate, from there. I'm really suspicious that crackling sound that we're hearing in the audio section, could easily be, a coupling capacitor breaking down, or it could be like a biasing resistor breaking down, or it could even be one of the tubes failing. But since we should replace all these capacitors anyway, because who knows how long they're going to hold up, I'll do that first, and if that fixes it, then we know what the problem was, and if not, we can investigate from there. So I'll do that, and we'll come back when that's done. Okay, so I've been working on recapping the audio section down here. So if you remember, there was that one capacitor that had the coil of wire wrapped around it. I believe that was this one. I'll just put a regular capacitor in here now. But it looked like that coil of wire came from this point, wrapped around the capacitor, and the end of that coil of wire connected to the input lead of the capacitor. So it looks like they were just trying to have like a small inductor in series with the capacitor. I didn't double check the schematic yet to see what the point of that was, but I've just put this in here for now, and we'll see how that goes. If necessary, I can take this back out and wrap some wire around it here if we really need that small inductor. But anyway, there's one electrolytic capacitor here. The rest were all the paper caps. And it turns out that this radio does actually use ceramic caps. Some of these fat resistor looking like things are actually ceramic capacitors. So yeah, don't really think I've seen that particular style before. Usually the barrel type capacitors are fatter than that. But anyway, this here is our says one of those canned ohm resistors, and this may have been the source of that crackling sound in the audio. You notice that there's a one lead here with a capacitor going to the audio output tube, and I noticed that this connection here seemed to be a little bit flaky. Like when checking the resistance from here to here and here to here, it seemed to vary a little bit. So what I did just for now is I took some pliers and I squashed this outer can here a little bit tighter, and it seems to have helped that somewhat. I don't know how long it's going to last, but at least for now we can see if maybe that takes away the crackling sound. If this was making a breaking connection or had a crappy connection to the nichrome wire inside here, because all that this is they got like a cardboard or phenolic former or something on the inside. Actually, you can kind of see it from this end. So you can see that this piece right here is, focus. Oh, you could see if it would focus, that this piece right here is the like cardboard or phenolic former, and then just take some nichrome wire and wrap it around that. And then they just lay these terminals on top, and then they wrap like this fish paper around it and then crimp everything down. So the only thing holding these connectors against the nichrome wire is the crimping force of this outer shell here. So, you know, if that gets weaker, or, you know, somebody disturbs it or something, could happen, or like corrosion gets in, you know, it could happen that these terminals start making bad connection to the nichrome wire in there. So we'll see if that helps or not. Another interesting thing that I've noticed is this capacitor right here is not connected to anything. So this lead looks like it was never connected to anything at all. So that's curious. I don't think there's a replacement capacitor. You know, this would have been the style they're using. There's several other of these in here. These Black Beauty style. So that's interesting. I wonder if that was a factory defect. I'll have to look at the schematic and see where this is supposed to connect to, and connect it to that. So anyway, now that I've replaced all the capacitors in the audio section, and now that I've crimped this back down somewhat, I'm going to flip this back down and see if that crackling sound goes away in the audio. And if it does, then I'll probably move on to recap the rest. And if it doesn't, then I'll probably spend a little bit more time trying to investigate where that's coming from. And then it might end up just replacing this whole thing as a next step, because even though, you know, it measures good on the ohmmeter, doesn't necessarily mean that it's, you know, 100% good. So, you know, that it's not noisy. So let's flip this back down here. Bring this up somewhat. Well, I could if my tripod would cooperate. Okay, I guess that's a good enough view. So I'll plug this in, make sure that it's turned off first. Yep. And let's turn it on. The one rectifier tube flashes pretty bright when it first turns on, so that's might have been what, if you saw that flash, that's what that was, the one rectifier tube. Flashes pretty bright initially. Let's see if the tubes are lighting up. Oh, I don't really hear the crackling sound anymore.
We're building a house now and have a couple of those.
Yeah, before, when I turn the volume down, you still get that crackling sound. No, I don't hear it. Just playing with the tone control a little bit.
So that helps support that bottom where that's sort of not a good thing. Is there another product that can be used if it wasn't installed on a bed already?
Yeah, I've heard of that being done that way.
So this seems to have fixed that problem, so that's good.
To go in from the bottom.
So I'm not sure whether it was that resistor or, you know, one of the capacitors, but, you know, if it comes back, then I'm going to assume it's that resistor that started, you know, making bad connection again, and I'll replace it at that point. But for now, seems like we solved our noise problem, so I'll move on to recapping the rest of it.
Then you apply it from there and just
The power switch seems pretty dirty. Nice blast of noise when you turn it off, so maybe I'll try cleaning that as well. So I'm actually starting to suspect that these Black Beauties might be replacements and not original. I clipped out this capacitor, which was living back here, and I noticed that I'm not sure if you'll be able to see this or not, but this lead right here is not connected to anything. Can't really. You can see the end of it's back there, not connected to anything. And that's not the one that I clipped. The one that I clipped is actually down here. You see that one's not connected. That's the one that I just clipped off that capacitor. But this one up here is also not connected to anything. So I'm wondering if this capacitor is supposed to connect from here to this disconnected lead here, and whoever replaced it didn't connect it properly, or didn't connect it at all, really. Another reason why I'm suspecting these two replacements is because look how crappy this joint is here. Looks like someone just like unsoldered the old capacitor and then they just kind of like globbed the wires or the leads back onto this terminal strip here. Because this looks like one of the original, either a resistor or one of those, probably one of those ceramic caps because it has an extra band on it. You can see like how, you know, none of the other solder joints are that bad except for that one. So that's another reason why I'm suspecting. Same up here. Look how much extra flux is on this one compared to, you know, any of the ones around it. So yeah, I'm starting to think that these are replacement capacitors, and whoever replaced this one just never connected this lead. So I'll look up, double check on the schematic that that's what's supposed to be there, and also check the function of this capacitor because the radio is working fine without this connected. So it's kind of interesting. But anyway, hopefully that mystery has been solved. Okay, so I replaced all of the capacitors. You can see the nice pile of them there. It always looks like more when they're piled up like that than when they're in the radio. But anyway, so I got all those replaced. I did power this up to test it, and the crackling in the audio circuit was back. But after about, 5-10 minutes or so, it completely went away. So to me, that seems like, something was warming up, and then when it got up to a certain temperature, it stopped crackling. So it could be a tube. It could still be that resistor. Maybe as that resistor heats up, the non-con wire expands a little bit and is enough to make a good connection to that terminal. Or it could be like any of the other resistors that are bad. Though I did check the resistors in here. I don't know if I mentioned that. I did spot check some of the resistors. I think I checked all the resistors in the audio circuit, and they're all pretty much on value. None of them have really drifted. There was one, I think 2.2 meg that drifted up to 3 meg, which usually is pretty good actually. Usually they drift a lot higher than that. But there's a couple 47 or 470Ks and stuff in the audio circuit that are right on. So it doesn't mean that they're not waking out on the load, but at least they haven't drifted. So still got to figure that out. Thought we solved it, but actually didn't. I can check and see if I have a resistor I can use as a replacement. It's a 2-section power resistor, so I'll have to find 2 resistors to replace it with. Something that is interesting that I haven't seen before. You can see this original filter cap here, and yes, I did not change the filter caps because there's no audio hum whatsoever, so I'm not all worried about those. But if you look at this, you can see it's 30 microfarad, and it says at 65 degrees Celsius it's rated for 475 volts, but at 85 degrees Celsius it's only rated for 400 volts. So that's interesting. I don't think I've ever seen that before, where they give you a temperature-dependent voltage rating on the capacitor. So as if you keep your capacitor below 65 degrees, you can get it up to 475, but if it gets up to 85, somehow it's no longer rated for as much voltage. So that's kind of interesting. So another thing I wanted to mention, like those capacitors are original. They look original anyway. They're Philco branded. The only original Philco tube seems to be this audio output tube. It looks like every other tube has been replaced. Some of these, like this one's a GE, this one's an RCA, this one's an RCA. So all different brands except for this audio output tube here. So I just wanted to bring that up. So this radio has definitely, seen quite a bit of use to wear out almost all the tubes. But anyway, we'll power this up and see if our audio crackling is there or not. If it's not there, then it's and then maybe my theory about it having to warm up is wrong. See, I plugged it in. Turn it on. I don't have my AM antenna hooked up, so I guess we only do FM for this test. So now there's no audio crackling. We're definitely getting more FM stations than we were originally. If you remember, originally we only got like 1 or 2 clear FM stations. The other ones were kind of garbled. But now, I know in the middle of the band, and so far we've got a few clear FM stations. So changing the capacitors definitely seems to have improved the FM sensitivity.
Lives on. Behind every faith.
The alignment might be a little bit off. It doesn't seem to have quite the selectivity that I guess I would expect.
So how many of us have lived in sweatpants, socks, and hoodies for the last couple of months?
All the way back down to the beginning. We started around the middle, so.
And unemployment rates for Hispanic workers shot past those for black and white.
Pieces on the floor, and words fall short in times like these. But this will drive. Tell your heart to beat.
Moms and dads, how many times have your kids asked you to tell them a story? Well,
Alright, so FM performance is definitely improved. Got lots of stations nice and clear. Like I mentioned, the alignment might be a little bit off. It seems like the stations start coming in, when you're going up the band, it seems like the stations start coming in a little bit, and then you get to the peak, and then there's a sharp drop off. So it seems like, maybe the discriminator is not, exactly centered or something. But I'm not going to worry a whole lot about that. Or it could be, like one of these IF cans is tuned like a little bit low, so that one starts peaking as you come up on the station. And then once you're actually on the station, like it peaks with the rest of the coils and the discriminator and everything. So not a huge deal. I'm not going to worry about that. I don't think it's worth it to try and fiddle with these adjustments for that minor annoyance, because the stations come in nice and clear, so the radio is working fine. You might get like a minor gain improvement out of that, but like I said, I'm not going to worry too much about it. So yeah, our audio crackling still has not come back, so like I said, I can check and see if I have a replacement resistor for that, and if I do, I can replace it, but otherwise we'll just run this and see how it does. And it shouldn't be silver mica disease because even with the volume turned all the way down, it was still present, when it's happening. So if it was silver mica disease, you'd only hear it, when the you only hear it like when the actual audio is going through these, through the IF and everything. With the audio turned down, the volume turned down, that should be cut off. So, well, I guess it could be possible that noise could be feeding back to the B plus, but I doubt it because that should be filtered pretty well. So I'm pretty confident that it's not silver mica disease. That it's definitely something in the audio circuit, but it's not there now. So you can't diagnose a problem that doesn't exist currently. So I think we'll just keep an eye out for that, and like I said, I'll see if I can place that. So I seem to find a light bulb here. I checked the schematic. This is just a regular 120 volt light bulb directly across the AC line. So in some of these radios, the light bulb was part of like the filament string. So like if the light bulb burned out, you get like, some of your tubes wouldn't have quite the right filament voltage across them. But that's not the case here. This is directly across the AC line. So shouldn't hurt anything that this is burned out, but it's obviously not going to light the dial like it should. So I'll have to find a replacement for that. But anyway, let me hook up the AM antenna. We can do an AM. Actually, I'll probably just put this back in the cabinet first. Then hook up the AM antenna, and then we'll do like a full FM AM channel sweep. And I think that'll be it for this one. So putting the back on, I'm not quite sure what the idea of some of these holes are. You see this one lines up with that blocked off control on this unit. This one lines up with where the phono would plug into if it wasn't blocked off. This one seems close to lining up with where that FM antenna plug is. I'm not quite sure what these two are for, but there's nothing down here around where the power cord would go. So I'm not exactly sure what the original intention of how the power cord came out here. I just put it out the bottom hole here. I don't know whether it was supposed to come out here and then have that FM antenna coming from the power cord on the outside and then plugging in there, or what the original deal was. I don't want to do that because like when that thing's like out on the outside, there's no strain relief on that white wire. That white wire is just soldered to that ring around the FM, around the line cord. So there's no strain relief on that little white wire. So if you flex the power cord any amount of times, that white wire is just going to break right off of that. So I don't want to have that on the outside. So what I did was I just left it on the inside. So then the strain relief is provided by that clamp around the line cord. I can't pull this out because that clamp hits against the back of this, the back here. That's not really ideal. I would rather have the strain relief be on the chassis, but I don't see really any way to do that. This back is pretty thick, so I'm not really worried that's going to break this, but it's just, not really ideal. But anyway, that's back on. Let's turn this around and we'll try it out. Let's we are plugged in. Yeah, so I'm not sure if you noticed it, but there are little rubber mounts that mount the chassis to the cabinet, and they are crushed a little bit, but they're not crushed enough to where these are rubbing, so where the knobs are rubbing against the cabinet, so I'm not going to worry too much about that for now. Cabinet's not necessarily the best shape, there's some scratches here and there. Might try some restore finish on it. A little bit of corrosion right there. Let's start at the bottom. This is FM, I believe. Yes, FM. These knobs, I might just end up scratching the rest of this paint off. I think they'll look just fine in, plain Bakelite. Or I could paint them a different color. But that just flakes right off, so that's not. I'll just leave them as the raw Bakelite for now. It'll look just fine, to be honest. That one is almost there already. Anyway, it'll look fine like that.
One of our gods, even though we have many of them. Don't be afraid. Daddy said we...
found asleep in his car at a drive-in fast food restaurant.
Cash is easy to get, then this might be the least expensive method to get in.
The guy who puts the flat Earth theory at one.
Straight in cash, just text the letters EDN to 878787. Again, text the letters EDN to 878787. All through.
See how that one kind of comes in twice though?
Qualified buyers get 0%.
Just faint there.
76-2020 plus.
A little strong there. So yeah, I think the alignment might be a little bit off. Like I said, I'm not going to worry about that right now. Let's go to AM.
Rose in New Jersey's on the line, and she has a very busy tree that's causing lots of problems with roots. What's going on, Rose?
We're clenched in fists of rage. No angel born in hell.
That comes in nice and clear.
Not happy, so this is what the scripture says. And they
show and listen to it, okay?
The graduation, but they're all sitting socially.
Never been more important. We can help.
Saying that if you adjust your diet, you can get to the nutrition.
In the studio, I have different things that they added. The DA.
Is one of 6 elected vice presidents with the NBA players.
But the other thing is, if you got to.
That's not why you got into this. That's why I think.
Oh, a decent reception on the AM too. So definitely satisfied with the performance of this.
There's so many different issues. Back, but.
The day, the music,
Of course, that's tone all the way to bass.
and they were singing.
I'm gonna get off that before I get a copyright strike. But anyway, that's going to be about it for this one. So I hope you enjoyed this video, and thank you for watching. Actually, there's one more thing I wanted to discuss before finishing this video, and that is, why did the FM performance improve by changing the capacitors? Because a lot of a lot of people just blanket change the capacitors for everything, but there has to be actually an issue, with one of the capacitors for changing the capacitors to actually have an effect. And it has to be like the only issue. If you just blanket change the capacitors and everything, you're not always going to fix everything. So a couple of theories that could be the reason why FM performance improved upon changing the capacitors. One, there was that capacitor that wasn't connected to anything. I think that was the screen filter on one of the IF tubes. So I wouldn't really expect performance to increase because of that. Maybe you get like a little bit of noise reduction or something, which actually we did have some noise, but it seemed like more like static noise, but could be the cause. Another likely cause is, if the capacitors get leaky, they could change the bias on the tubes and then throw the tubes into the wrong conduction area. That's generally, I think, a lot of times what causes issues with these old radios is when the capacitors get leaky. Your grid bias is off, and that drives the tube the wrong way, and just is not operating in its ideal operation point on the conduction code. So that I'm gonna assume that one of these capacitors was leaky and was driving one of the tubes into the incorrect bias. My theory anyway. Could have been the misconnected capacitor or the non-connected capacitor, but I'm kind of thinking that it was it was more likely that one of the tube biases, or more than one of the two biases, was wrong. The fact that it worked for AM but not FM, leads kind of narrows down the area of issue probably to the FM RF amp or the FM oscillator, because this uses a separate FM oscillator tube. There's another interesting thing that I wanted to discuss as well, because a lot of people say that Philco is low quality, but this radio actually seems over-engineered compared to something like a Zenith from a similar time frame. Zenith from this time frame, 1948, 1949, they'd already gone to selenium rectifiers. They had basically the same design that they use all the way up into the mid-1960s, where you have like your FM RF amp, and then your FM AM mixer oscillator, and then your 1 or 2 IF stages, and then they actually use the same detector, ratio detector and first audio that this uses. I think it's the 19T, I think it was. Zenith used the same one from like 1947 all the way up, I think, till like the 60s. I believe they used that too. Anyway, my point is that this radio at this time is definitely, a more complicated design than what Zenith was using. Now, whether that's because Zenith had engineers that were better at optimizing designs than Philco did, or whether because Philco actually truly believed that building the radio this way made a better radio, I'm not sure. But this radio has the double rectifier tubes with the voltage doubler, which is actually pretty unique, I think, at this time. Like I said, Zenith had already gone to selenium rectifiers at this time, which is just a half-wave rectifier. I'd worked in an RCA radio from a similar time frame that just used a regular rectifier tube, no voltage doubler. So this also uses the separate oscillator for AM and FM, and it also uses separate IF transformers too for AM and FM. Like, that's another thing that Zenith did. Zenith had their AM and FM IF transformers under the same can, whereas this uses separate cans for both. Now that's not necessarily a feature unique to Philco. Some other manufacturers did that too. I just think it's interesting that Zenith is held up as like the top highest quality, but comparing this radio to a Zenith, this one actually looks like it's a better design, and definitely more expensive to make than a Zenith would be, because it's got the extra parts, the extra tubes. But anyway, it's something I wanted to bring up because I think it's an interesting design on this one. But anyway, hope you enjoyed this video, and thank you for watching.